Exponential, thank you. That's a good thing we're doing today. We're finishing week 8. What I want to point out is, what I couldn't believe is that November 2nd is only 2 weeks from today. That seems soon for another quiz already. 2 weeks though, that's a long time because we have a lecture today, then 2 lectures next week, then 1 on Tuesday the week after, then a quiz. So you still have 4 lectures, 3 after this one. So there's a lot of material still coming at you for the next quiz. But here's the material today. Exponential, exponential, exponential. A little review of Tuesday's Excel portion of exponential, but it's really highlighting manually how to do exponential. Now I want you to see this manual formula because it's weird. In the past, we've always subtracted from 1 when the question was a more than question. But with exponential, the manual equation subtracts from 1 when it's a less than equation or question. So this is weird. I want to make sure you heard me. In the past, almost every equation we did, you subtract from 1 when it's a more than. But the manual equation for exponential is subtracted from 1 when it's a less than. And when it's a more than, it's subtracted from 1 twice, which cancel each other out, which leaves it with no subtracting from 1 at all. How crazy is that? Let me repeat this because this is so weird. It's so backwards compared to normal. If we have an exponential question that's a more than, go back to Excel. We always put a 1 minus when it's a more than. That's just our habit, and that's how it always is. But manually with exponential, the 1 minus goes with or less, some number or less, or no more than, or it means a number or smaller. It's the more than that gets subtracted twice, which ends up canceling each other out, meaning e to the power of with no subtraction at all on a more than. It's the complete backwards of logic from everything we've learned. That's why everybody kind of gets this one, finds this one hard, only because it's backwards compared to logic. So, with that said, I want to refresh your memory on Lambda. Don't forget, all of Tuesday and today is about Lambda, Lambda, Lambda. This is what exponential is all about, this Lambda. And in the manual equation, in that exponent, in that parentheses there, is Lambda. The same Lambda that we use for the center number when we're using Excel. Same exact Lambda. So let me read this equation to you. 1 minus e, we all know e is 2.71828 or whatever your calculator puts e at, to the exponent of lambda times negative x. Negative x means whatever the number, the interval the question's about, hey, what's the probability there'll be 5 minutes between the next 2 cars? 5 is your x. But you've got to make it negative when you're using the manual equation. You have to turn it negative. And then multiply it times lambda. Now it's the exponent to e. How weird is this? You've got to see some examples to really embrace this. Let me see if there's anything. Let's go back to lambda real quick. Hey, the mean says, there's 5 minutes between cars on average at this toll booth. Okay, well, how many cars then will there be in 1 unit? The question's about what's the probability of being 4 minutes between the next 2 cars? It's in minutes. So lambda will be the average number of events during 1 unit of the interval being asked about the question, which is minutes. So how many cars would that be in one minute? Lambda's all about how many in 1 unit of the interval in the question. If it's minutes, how many in 1 minute? If it's hours, how many in 1 hour? If it's 1 mile, how many in 1 mile? If it's 10 feet, how many in 1 foot? Get it? It's in 1 unit or whatever the question is lambda. So now, before we go through some examples, I want to test your ability to, I've never done this before. I made this up yesterday. I was going to say last night, I think it was yesterday afternoon. I've never done this before, but I want to test your ability to recognize what kind of question you have in front of you. Is that Poisson or is that exponential? Bats can consume an average of 10 mosquitoes per minute. What's the probability that the time between eating mosquitoes is less than 15 seconds? Poisson or exponential? Exponential. Why? Who's willing to tell me, volunteer and tell me why? Go ahead.
It's about time between.
Because the time, the interval is being asked about is the 15 seconds. Because the question's about an interval, that's how you know it's exponential. Do not let the description of the mean, the average of 10 mosquitoes per minute, have anything to do with you deciding whether this is Poisson or exponential, because that exact description could be either Poisson or exponential when describing the mean. You gotta look at the question to determine what kind of question you have. The question says, what's the probability that time between eating mosquitoes is less than 15 seconds? It's asking about an interval of 15 seconds. You now know it's exponential. All right, let's go to the next one. Exponential or Poisson? 4 flaws occur every 60 yards of material produced. What's the probability of 3 or less flaws in 60-yard piece of material? Why?
No time.
What do you mean no time? No, it's not because there's no time that it's Poisson.
Oh, because it's asking like what's the probability of a 3 or less?
Of how many, it's asking you the probability of how many per an interval. Because it's asking you how many, which is Ali was getting to here, 3 or less flaws is the event. Because it was asking the probability of how many per an interval, that's Poisson. That's what it is. You've got to look at the question part to decide which it is. If it would have said, what's the probability of 60 yards between the next 2 flaws, then it's exponential. Because it's asking you the probability of the 60 yards. But this is asking you the probability of 2 to 3 yards, 2 or less flaws in 60 yards. It's asking you about the probability of the flaws. That's what makes it Poisson. All right, next one. Exponential or Poisson? On average, there are 5 potholes per 6 miles of a particular highway. Now that could be either one. That description of the mean could be either one. What's the probability of 4 potholes in a 6-mile section of this highway? Poisson or exponential? Exponential or Poisson? Poisson, because it says, what's the probability of 4 potholes? Because it's asking about the 4 potholes, that's how you know it's Poisson. If this would have said, what's the probability there are 2 miles between the next 2 potholes, now it's exponential. Because it would be asking you the probability of the 2 miles. But this one's asking you the probability of 4 potholes in an interval. That question about the potholes, that's the event, is what makes it Poisson. All right, if you guys have these down and can figure out whether it's Poisson or exponential, you're saving yourself, that's a whole grade difference on the next quiz and the final exam. Because that's the #1 mistake, you're confusing these two. And you took all that time to calculate it as Poisson when really it's exponential, or vice versa. Here's one, I think I have one more. Exponential or Poisson? The average time between email messages during working hours equals 15 minutes. What's the probability there'll be 30 minutes between the next 2 emails?
Exponential.
Exponential, because it's asking about the interval of 30 minutes. The question's about the interval of 30 minutes. That's what makes it exponential. You can't let that average time between emails. That average time between email description for that mean could be either one. The Poisson describes it that way sometimes, exponential describes it that way sometimes, they interchange. But the question itself, if it's about an interval like this one is, 30 minutes, that's how you know it's exponential. I think that's last. I don't think I have another one. Let's make sure. That was it? Good. All right. That makes me feel good. You guys are on top of that. Here's the instructions. You have 2 assignments. They're due on Tuesday, 5 days from today. Your written assignment and an Excel assignment. Here's the written assignment. I can't believe it. For some reason, there's only 2 questions on the written assignment. I don't know how that happened. There should be more.
No, it's 2.
And the written assignment means you're solving it manually. Using these equations right here, showing step by step your work. I want to make sure you get all the points on your homework as well as all the points on the next quiz. Show your work how you calculated lambda. Show your work how you determined what lambda is. I must see that. Then you plug it into the formula. You only have 2 of them. I almost want to read them. That's too thin. Hang on, I'll come back if we got time. Now, Excel. Excel, you have 6 questions. We looked at this on Tuesday a little bit. Number 1 describes the mean, and then it asks 3 different questions. And number 2 describes the mean, and then asks 3 different questions. The tricky part on this, I gotta find it here, is right here, 2C. It says, what's the probability a customer arrives in a half hour or less since the previous arrival. It's asking you about a half hour. You can switch that to 30 minutes, and now Lambda has to be how many in 1 minute? Or you can leave this as a half hour. Lambda has to be how many in an hour? Let me repeat this. If you leave this as a half hour, x is just 0.5, a half. Lambda is how many per 1 hour. If you decide to switch this to 30 minutes, x is 30 instead of a half, but lambda is how many per 1 minute instead of an hour. So it's up to you. I'll accept either answer on that 2C. However you decide. That's probably the only tough one on here. Out of all the homework, probably the only tough one. But I'm accepting 2 different answers, so you should be okay. You're gonna get the same answer. It was just a matter of using the right numbers. Everybody understand what's due on Tuesday? The 2 written assignments and 6 Excel assignments, okay? I think that's it. You have had such a light homework load in this class. We've got to step it up. What? But don't you want more homework so you do better on the quizzes?
No.
What? No, that doesn't help? Please tell me you're recognizing though that some of the quiz questions are directly related to the homework.
Yeah.
Okay, good. Because I hear that's rare sometimes. Is that true? Anybody? No? It's not rare, it's just a rumor? All right. All right, what's next? What are we going to here? We're gonna go to the example on the PowerPoint. Okay, we solved this on Tuesday using Excel, but now we're gonna solve it manually. The time between arrivals at A1 or Al's, I don't know if that's a 1 or Al, Al's full service gas pump follows an exponential probability with a mean time between arrivals of 3 minutes. So here we go. We got 3 minutes. It's being described to us as the time between arrivals, our average time. So it's being described as an interval. It's not being described as how many per minute, or how many per half hour, or how many per 30 minutes. Instead, it's giving us the time, 3 minutes. Either Poisson or exponential can describe that mean either way, so you can't determine what you have based on that description. You got to go on to the question, which says, Al would like to know the probability that the time between 2 successive arrivals will be 2 minutes or less. So 2 or less is the question. This is the part we don't switch. 2 is our x, and if we're solving it manually, it says 2 or less, so that's the top one, where we're subtracting from 1, which is weird, because we subtract from 1 usually when it's greater than, but this says or less, we're subtracting from 1. So this is gonna be 1 minus e to the negative 2. I can get that far. I'm going to put parentheses next to it, and now all I have left is lambda. I'm using negative 2 because it said 2 or less, and the manual equation says turn it to a negative exponent. Negative 2. Lambda, here we go. 2 or less minutes. Lambda has to be the number per 1 minute. Currently, all we know is there's 3 minutes between each one. Now, because it's being described as an interval of time, we go, okay, that's 1 per 3 minutes. If you want to do cross multiply, 1 times 1 is 1 divided by x times 3, so 1/3 is x. Or you could just use logic. You go, if it takes 3 minutes for 1 car to go by, how can there be any cars going by in 1 minute? There can't be, because there's 3 minutes for just 1 car. So if I have to figure out how many cars are in 1 minute, and it takes 3 minutes for a whole car, I'm going to split it up in thirds. 1/3 of the car in the first minute, the second third in the second minute, and the last third of the car in the 3rd minute. Now we've got 1 car. So 1/3 of the car goes by each minute. So now this is 1/3. Or you want to turn it to a decimal, 0.3333. Give me at least 4 or more 3s. 0.33333. There it is, and then you just manually solve it. I want to show you on a calculator, just so some people want to make sure you see how to do this on a calculator. I'm sorry, 1 minus e. I'm not even going to do the 1 minus. I'm just going to do the e and then subtract it from 1. E, and now I'm going to this x to the power of y key, so it's making ex, and now it's asking me what will be the exponent for y. To the power of, I'm using parentheses, because I want to multiply these two. Matter of fact, I should have done that first. To the power of, parenthesis, 2, which is negative, times, I'm going to turn it to a decimal, 0.3333, I'm using a bunch of them. Now I'm using my right parenthesis. There's the exponent, negative 0.666666. E to the power of negative 0.666 equals, here we go. There it is. So now we're at 1 minus 0.513. 0.513, is the next one a 4? What's the next digit after that? 4. Because the next one's a 1, so I leave it as a 4. I don't round up. There it is. But we have one more step now. We have to subtract it from 1 to get our answer, which is the weird part. So here's how I do it. I make it negative, and then I put plus 1. So it should give me the opposite of 53%, I'm sorry, 51%. Did I write the wrong number? Was it 53 or 51? Okay, which would be what, 48 point, a little over 48%? There it is. Equals 0.48, gotta go 4 digits. 66? 66, because the next digit's a 5, so I gotta round up, or 8, so I gotta round up. There you go, there's our answer. If usually A1 gas pump, a car comes up every 3 minutes, the probability of a car arriving in 2 minutes or less is just shy of 50%. Now I want to ask you a question. I know you have a question again. I want to ask you a question. You may answer it. What if it would have said, what's the probability that there'll be 2 minutes or more between the next 2 cars at the gas pump? We already calculated the answer. Because if we're doing a more than, everything's the same, but when you subtract it from 1, you then subtract it from 1 again. So all I gotta do is take that and subtract it from 1 again, and I'll have the more than. But the thing is, when I subtract this from 1, I went right back to the 0.5134, which is what I'm trying to save you time. Because 1 minus 1 minus cancel each other out is just on a more than question would be e to the power of the exponent. So my answer for the more than is right there. The probability of it taking 2 minutes or more is about 51%. The probability of it taking 2 minutes or less is about 49%. We did them all in one equation. Now,
for the more than, you see how it says 1 minus 1? That cancels out. Isn't there still a negative for like negative e of negative x?
no. I'll take it step by step though. Watch what happens. I went right here with 1 minus e. You do all the e first, then you subtract it from 1. But then the next step now is whatever you have, subtract from 1 again. You've got to do order of operations, so that's why it doesn't leave a negative. So with order of operations, now I'm going to do 1 minus 0.4866, which equals 0.5134. Takes me right back to the equation had I had no 1 minuses in front at all. So order of operations allows you to just go right back to the e. They cancel each other out. So this is, again, this is so weird. I'm going to repeat it again because it's just so weird. With exponential, manually calculate with the manual formula, if it's a less than question, you're subtracting from 1. If it's a more than question, you're subtracting from 1 twice, which means you're not subtracting at all. Which is the opposite of logic. So that's why I'm emphasizing it way too much. I want to Mr. Thomas guy. All right. What? Here we go. So just look at the thing. 1 minus 2.71828 to the power of 2/3, right? We said 0.666 we had after we took 2 times 1/3. Got 5134, we subtract that from 1, we get 0.4866. Let's do another one. I'm gonna go to your book, page 228. I got this PDF though, but it is, I looked it up, it's page 228, number 66B. 66B. Hang on, I want to erase this. I want the manual, I want help doing the manual equation. Get this all off here. Hang on. Okay, here we go, manually figuring this one out. 66B says, a toll booth operator has observed that cars arrive randomly at an average of 360 cars per hour. 360 cars per hour is how the mean is being described to us. The exact same way Poisson describes the mean, by the way. B says, what's the probability the next car will arrive in 10 seconds? 10 seconds. Okay, remember this from Tuesday? First of all, 10 seconds. We know we're going to use 10, and Lambda has to be how many cars on average arrive at that booth per 1 second. So we gotta convert this 360 an hour to how many per 1 second. But meanwhile, we're putting a 10 here. So we can go, and is this 10 seconds or less, 10 seconds or less, or 10 seconds or more? 10, arrive within 10 seconds. That's the same as 10 seconds or less. So here we go. This is gonna be 1 minus e to the power of negative 10 times lambda. That's how easy this is. You just set it up just like that. Now, lambda, this is 60 minutes. So if we take 360 divided by 60, which goes 6 times, is that right? That's 6 per minute, but that's 60 seconds. So if I take 6 divided by 60 again, I get 0.1 per second. So now lambda is 1/10, or 0.1, same thing. There it is. And then you just do the math. It's whatever you're being asked about made negative times lambda as an exponent. And then you do e to that, and then you subtract from 1. So now, when I do e to this negative 10 times 0.1, I found if the question said 10 seconds or more. But when I subtract it from 1 is when I find for the answer 10 seconds or less. Go ahead.
So you're just trying to find it for 1 second, one of that.
Only because the question was about 10 seconds, so it has to be one, however many events take place in one interval of the, 1 unit of the interval being asked in the question. Because that was about seconds, I had to convert this 360 per hour to how many per 1 second, yes.
So if that was 60 minutes, it would be 1 minute?
If this question said, what's the probability that the next car will be within 60 minutes, is that what you're saying?
Yeah.
Then you have to find for 1 minute, which is 6 per 1 minute. Yes, whatever, then 6 would be lambda, 60 would be x. Because it's in minutes, how many per 1 minute, absolutely. Go ahead, question, Colin?
Yeah, I was gonna ask about how you broke that down again.
Oh, I got it down to 0.1?
Yeah, I still don't.
Okay, so I said, well, if it's 360 per 60 minutes,
Right.
I can go ahead and get that down to how many per 1 minute, because I just have to divide by 60 to how many per 1 minute, because there's 60 minutes.
Right.
So 360 divided by 60 is 6. So 6 per 1 minute, but I need how many per 1 second. So I said, well, how many seconds are in a minute? 60. So I took 6 divided by 60 equals how many per 1 second then? And that 6 divided by 60 ended up being 1/10, which is the same as 0.1. But I had to go from minutes or hour to minute to a second. I know, that wasn't easy. All right, let's go to the next one. We're going to 67C. 67C, 67 says, let me erase this. Customers make purchases at a convenience store, arrive at the cash register on an average of every 6 minutes. So now it's telling you there's 6 minutes. Instead of telling you how many, like this last question, this time it's giving you the mean as an interval. Again, we don't know what kind of question this is, it could be either one, but it said 6 minutes between customers. There's our mean. Every 6 minutes, and we're doing B or C? We're doing C. C, what's the probability a customer will show up in less than 5 minutes? So 5 minutes or less. Here we go. 1 minus e to the power of -5 times lambda. All right? The question's about 5 minutes or less. I'm using the equation for the less than. I put the -5 there, and now I just gotta figure out lambda. Because the question's about 5 minutes or less, I gotta convert 6 minutes into however many per 1 minute. And this is 1 per 6 minutes. 1 times 1 is 1 divided by 6. 1 over 6. 1 over 6. You can turn that to a decimal if you want. Yeah, let me make that a good one. And there's lambda. Since this says 5 minutes or less, I'm going to do Excel. There's no 1 minus in front. The first number right here is whatever we're being asked about, which happens to be a 5, comma, lambda, 1/6, comma. What number is always on the end? 1 it is. Oh my God, these are becoming easy. We're doing so many of them.
Question was 5 minutes or less, you use 6 because it's more?
No. We always use with exponential, whatever number is being asked about, we never switch it.
Where'd you get 6 from? 6
The
minutes?
it said that on average, there's 6 minutes between each, I think it's 6 minutes between each customer. There's 6, it says, customers make purchases or come up to the cash register at this convenience store on average every 6 minutes. So that's the mean. The 6 minutes is the mean. I had to convert it to how many per 1 minute. If one customer is in 6 minutes, 1/6 of the customer is in 1 minute. And that's how I got the lambda then. But the question's 5, we won't change that number. I guess if we changed it to whatever portion of an hour it is, then this would be how many per 1 hour? And 6, that'd be 10, because there's every 6 minutes, there's 60 minutes an hour, it'd be 10 of them an hour. But anyway, forget that. Let's go to the next one. We're going to 70 now. Is it, can we see 70? No. Oh, I'm sorry, 68.8. We're going to 68.8. Hospital administrator worries the possibility of a loss of electric power because of a power blackout. The hospital, of course, has a standby generator. It's subject to failure, though, having a mean time between failures of 500 hours. Here's the average time. 500 hours. 500 hours per, wait, I'm sorry, hang on. I gotta make sure I did this right. 1 failure per 500 hours. It's 1 failure per 500 hours is the description of the mean for number 68. Then it says, are we doing B or A? We're doing A. What's the probability that the standby generator fails during the next 24 hours? The question is about the next 24 hours means 24 hours or less. We're doing the top one. We're doing this one right here. Let me get rid of this. 1 minus e to the negative 24 hours or less. Because this is in hours, we now gotta know how many failures we have on average per 1 hour. We don't get a failure for 500 hours. So 1 times 1 is 1 divided by 500. That means we get 1/500th of a failure every hour. Until 500 of them go by, then it's a real failure. So our lambda ends up being 1/500. You're starting to see a trend here, that when the mean is described in time, it usually ends up being like 1 over it, but don't count on that. Think it through. But when the mean is described on how many, then you kind of got to put it up and do your cross multiply. But I do cross multiply every time just so you can see it always works, even if it was time or how many. So you can see it always works with either one. But you'll start getting used to these. Let's do it now. There it is, set it up using manually. Let's use Excel. It's asking about 24 hours. So 24 is the first number. Lambda, 1/500. How many per every hour? Comma 1. There's Excel.
That's for less than, right?
That's for less than.
2 is more than. What's the set? What's?
You want me to switch more than?
I know it's always
Let's
more.
pretend now this is 24 hours or more. Hang on. So if this is 24 hours or more, all I gotta do is take this and go e to the negative 24 times 1/500. And there's no 1 minuses in front. That's the more than right there. Now we'll go over here. This is asking about 24. The lambda is 1/500. 1, there it is. The only difference is the 1 minus in front. All right, this is it. It's time for a challenge. Think it through. Here we go. What's the probability that the generator will break down in between 24 and 48 hours? Here we go, this is the challenge. You're now being asked to find the exponential probability between two numbers, not just one number. Between two numbers. There's an extra step involved. You solved each number as if it's its own exponential probability question. Then you subtract the results. So you gotta do it twice. You're gonna have this on your quiz. That's the advantage of showing up today. You will be, or your final, one or the other. You will be asked to find the probability between two numbers. Not only using the exponential, but when we get to your final exam, you'll be asked to find the probability between two numbers for normal probability also. Which we're gonna learn in about a week or two.
Will we use the less than for both?
In this case, you should use the less than for both, but you will get the right answer if you use greater than for both. As long as you're using both the same, whether it be less than or greater than, as long as they're both the same, you'll get the right answer.
We gotta solve this?
You want me to?
Yeah.
Okay. Go ahead.
Can we just do one more example?
Oh, I'm gonna do more examples. I'm gonna do more examples, but I wanna solve this one real quick. Okay, you ready? So, hang on, here's 24 hours or less. So the other one would be 1 minus E, 48 hours times 1 over 500. Now I would take the result, the bigger result, minus the smaller result. And that's it, manually. Let's do Excel now,
Why is it
ready?
not negative 48?
What would I do? Oh, I'm sorry. Thank you, negative 48. Thank you. Thank you. Here we go though. Up here now, we're doing Excel. I'll just go right here. 48 is gonna be bigger, so all I'm doing right now, I'm gonna make this one to 48 minus, look at no equal sign, just minus. Now this one's the 24.
That's how you do it?
That's it.
Alright, but I solve that
One exponential Excel equation minus the other exponential Excel equation. The bigger one minus the smaller one, that will give you the probability of that generator failing between 28 and 48 hours. Go ahead.
Do you gotta put that in the calculator, like on the quiz, or going to the left?
You wanna see this in the calculator? Is that what you
Like,
said?
do we gotta solve it all the way through?
Oh,
Is that-
absolutely. Yeah, but my grandmother could solve it, she's dead, so I know. That's how easy this is. All right, are you ready? Once you solve one of these, anybody can solve them. I mean, they're easy to solve. Here it is. I'm gonna do this one first. So you can see, E, here we go. You know what I'm gonna do this time? I'm gonna find this exponent, then put E to it, then subtract it from 1. So let me clear everything. I'm gonna find that exponent first, which is negative 48 times 1 over 500. 1 over 500 times 48, but before I hit equals, make it negative, equals. So here's my exponent, negative 0.096. So I'm gonna save that in memory here. There's my exponent. Now I'm gonna take E to the power of, recall that number, negative 0.096 equals, so now I'm gonna subtract it from 1. So now I take this, make it negative, add 1, so now I'm subtracting it from 1, and I get 0.0915, does that sound correct? 15 minus, now we do the other one.
Why'd you calculate it backwards?
I don't know what you mean by backwards, but.
Like, you started from the right side.
Yeah, I know, because step by step, it just makes it easier, really. 1 over 500 again. Equals. Now I'm multiplying that times 24 this time instead of 48. Negative 24, excuse me, negative 24. This time I get negative 0.048. I'm gonna save that. I'm gonna take E to the power of, I'm gonna recall that number, negative 0.048 equals. There's that. Now I'm gonna subtract it. I make it negative, add it to 1, so subtract it from 1. This is gonna be 0.0469. And now I subtract the two. 9% minus 4.5%, equals about 5.5%, or about 4.5%, excuse me. So I'm gonna take 0.0915, 0.0915 minus 0.0496, is that what that says? No, not 9669. 0.0469 equals, here's our answer, this equals 0.0446. There's our result between two numbers. Let's use Excel to do it now. See if we get the same result. We'll check ourselves. Hang on, I gotta get a different spreadsheet. New. equals exponential dot dist parentheses 48 comma 1 over 500 comma 1 parentheses minus expon dot dist parentheses. Any mistakes so far? We're good still?
You did the exponent.
Yeah, I sure did, didn't I? Again, that's supposed to be an N there. There we go. How's that? I knew I did something. This time 24 hours, 1 over 500 comma 1. If I did this right, we should get about 0.0446 or darn close. 0.04467. All right. Everybody, can you solve these using Excel or manually? They're not that hard. The hardest part is remembering all that, what you gotta do. We got time for 2 more examples, and then we have it in class.
Can you do it manually one more time, just like in the calculator, how you did it?
How to do this part right here?
In the calculator?
All right,
Is that actual?
you ready?
Yeah.
Okay, he wants to see how to, let me clear everything. How to do it in the calculator the way I did it. I do an order of operations. I start out with the exponent. I'll save that, then I'll take e to that exponent, then I subtract it from 1. So that's kind of what I'm doing. So I'll start out with negative 48 times 1 over 500. 1 over 500. There's that. Times the 48. But the 48's a negative, so I gotta make it negative. So I got 0.002 times negative 48 equals. There's my exponent, negative 0.096. I'm now gonna put that up in memory so I can bring it back as an exponent. So I just have it saved now in memory. I hit my M plus. So now I'm gonna take E, 2.71828, and then I'm doing x to the power of y, saying here's my x. Now I wanna tell it what the exponent's gonna be. I hit recall on memory to bring back that negative 0.096. So I have 2.7 e to the power of negative 0.096. So when I hit equal, I have, if this were 48 hours or more, when I hit equal, that's the answer. But I have to subtract it from 1 because it's about 48 hours or less. So I'm about to hit equals. There's the probability that the generator will fail in 40 hours or more. Meaning, there's less than 10% chance of it failing in the next 48 hours, but there's a almost a 91% chance that yes, after 48 hours go by, it might fail eventually. Because it's assuming you're leaving it on for infinity hours. Yes, it will fail eventually. There's over a 90% chance it will once you get past the first 48 hours. So there it is if it said 48 hours or more. I'm now gonna make it a negative. I'm gonna add it to 1, so that's 1 minus that 91%, which will leave us with about 9% chance of it failing in the first 48 hours. How's that? Everybody see how I did on the calculator? All right, let's do one more example, at least. We're gonna do number 70, let me scroll down. Oh, you know what, I think we gotta go to a different page. No, it's on the same page. Yeah. On average, the state police catch 8 speeders per hour. 8 per hour, here we go. This time it's not giving you the time between speeders. It's telling you how many per hour. Again, just like Poisson does. So it says on average catch speeders 8 per hour. We're doing B. B says, what's the probability the state police will wait from 15 to 20 minutes? 15 and 20 minutes for the next speeder. And what's the probability between 15 and 20 minutes? So we're being asked about 15 and 20 minutes. We have to do this twice. Here's a perfect example. Am I doing the right problem? Between 15 and 20 minutes, right? So we'd have to find the probability for 15 minutes or less, find the probability for 20 minutes or less, subtract the 2 results. Let's just look at Excel real quick. Wait. Hang on, let's go back here. We haven't figured out lambda. So I got 1 minus e to the power of, we'll do the negative 20 first. Negative 20 times lambda. And then we also have 1 minus e to the power of negative 15 times lambda. Those are our 2 equations. Up here, hang on a minute. We know the probability for 20 minutes, is that minutes? 20 minutes or less, 20 seconds or minutes? 20 minutes or less is the bigger one, so 20, then lambda, then a 1, and the smaller one's gonna be 15, lambda, then a 1. There it is using Excel. The difference between those to find that probability between 15 and 20 minutes. Now, since this is in minutes, we gotta find the probability per 1 minute. How many speeders get zapped per 1 minute? If it's 8 per 1 hour, which equals 60 minutes, cross multiply. 1 times 8 divided by 60. 8 divided by 60 is, not all ones.
0.133.
0.133. 8 divided by 3333.
Yeah.
All right. So there's lambda. Here we go. 0.1333. 0.1333. You know, you could have left it in fraction form, which would have been 8 divided by 60 would have been 2, 1 divided by what? 2 divided by what? No one. Okay, here we go. 0.13, and right here, 0.133333. There it is. Most of the points are in the setup. The rest is just a little algebra. Just show some calculations and get a result. Show the result for each one and then show you're subtracting them. C says, what's the probability the state police will wait more than 25 minutes for the next speeder? More than 25 minutes. More. Or more. So in that case, we'd be using this equation, the more than equation. E to the power of negative 25 times lambda, which is 0.1333333. That's the equation because it's a more than, 25 minutes or more. How many per 1 minute? We already have lambda. These aren't that bad. These aren't that hard. It's just, we make sure we see enough of them. You want to see one more? Go ahead.
More than you do 1 minus 1.
No, 1 minus 1 minus cancel each other out, so you only got to do e to the power of.
Oh.
Because 1 minus cancel each other out. Don't get me wrong, if this confuses you, take that, subtract it from 1, then whatever you get, subtract it from 1 again. It will bring you right back to this original calculation, but if that helps, do it. Subtract it from 1 twice.
So,
How are we doing on time? We're doing okay? We can do one more. I'm going all the way to page 234 from your book. Page 234, we're going to look at number 87. Right here it says, on a particular busy section of Garden State Parkway in New Jersey, police use a radar gun to detect speeders. That's just like the state police one we just did. Assume the time elapsed between successful speeders is distributed with a mean of 15 minutes. So this time, the other question said we get 8 speeders an hour. This time is telling us the interval between speeders, which is, which one we just do, 88 or 87? 87, which is 15 minutes. 15 minutes per 1 speeder. 1 per 15 minutes is telling us. This time is different. So 1 per 15 minutes equals how many per, what's the question about though? Is it about a minute? Is it about a second? Is it about an hour? We'll look at the question. We're doing B, I think. What's the probability the waiting time is less than 10 minutes between speeders? So the question's about 10 minutes or less. Hang on, I'm going up here. All right, so this is going to be 1 minus e to the power of negative 10 times lambda. There it is, 10 minutes or less. 1 minus e to the power of negative 10 times lambda. Lambda is how many in 1 minute? If there's 1 every 15 minutes, there can only be 1/15. And you can turn that to decimal if you want, leave it as a fraction. I'm going to leave it as a fraction, 1/15. There it is. Now I'm going over here. I'm going to solve it using Excel. We're being asked about 10 minutes, comma, lambda's 1/15, comma, 1. There it is. These are becoming easy now. Is it just me? There they are. We got it. We can do the homework. Anybody have the homework done? You got it done? All right, catch them on the way out. You have your camera ready. Thanks, Scott. You like that one? Weren't you late?
No, I was ready.
Just checking.
I was early.
Oh, I didn't get the email.
No, like, it was.
Screenshot, what happened?
No, I came for a check.
Oh, okay. All right, any questions? Are we ready? Are we ready to do it on our in class? Go ahead, Ryan. You wanna do part C? Part C says, what's the probability the waiting time is excess of 25 minutes?
So that's more than?
So that'd be more than 25 minutes or more. So I'm gonna switch this to 25 minutes or more. Notice that because it's in minutes, lambda is still 1/15 of a minute. So all I gotta do is, because this is a more than, it'd be e to the power of -25 times lambda 1/15. That's it for the more than.
If you do 1 minus 1 minus, will it change the answer?
No.
That's what it says.
You can put 1 minus in front, but you're coming right back to this calculation right here. So you're just kind of wasting time. That's all. Doing it twice, but that's okay. If it makes it more understandable, I'm okay with that. Bring on, show the work.
So when it asks about a between two numbers, like 24.
Make them both less than.
It's less than?
Make them both less. It's the easiest way to do it instead of the more than. Let's do this more than right here. 25 minutes or more with Excel. Excel, I'm just gonna do the 1 minus exponential distribution. It's asking for 25 minutes or more, so there's 25. Lambda is still 1/15, comma 1. There it is. There's for the 25 minutes or more. All right, while this is fresh in your mind, I'm gonna put this in class up. It's always a 1 on the end for exponential. Is that what you asked? Yeah, always a 1 for exponential. Normal probability always has a 1 on the end also. Binomial and Poisson, you gotta think about what goes on the end. But for exponential and normal, always a 1.